Hello, this is Mr. Stansbury. I'm going to take you through the 12 E-notes on compound interest. At the end of this, you should be able to say that I can use the compound interest formula to find various rates, investment amounts, and investment periods for given real-life situations. Okay, so let's take a look at what the compound interest formula is. Okay, compound interest formula is A equals P times 1 plus R over N to the NT, where A stands for the current amount or the newer amount. P stands for the principal amount, which is the investment amount usually, okay, or the older amount. 1 is 1. R stands for the interest rate as a decimal. Both of these N's here stand for the number of compounding periods per year. And then the T is the number of years of investment. Okay? And just really quick on the N's, the compounding periods per year. If the interest is compounded annually, that just means that would be 1. If it's quarterly, that means that these compounding periods would be 4. If it's monthly, it would be 12, because there's 12 times that you're compounding the interest. All right? Okay, with that, let's take a look at some examples. Okay, first one, example 10 from page 408 says we have $5,000 is invested for 4 years at 7% compounded interest, which is compounded annually. How much will it be worth in 4 years? Okay, so let's start with our formula. Let's see here. There we go. A equals P times 1 plus R over N to the NT power. Okay, so $5,000 is our investment. That's considered to be the initial amount. That's the principal. That's the P. So we get 5,000 here, and then we're going to do 1 plus the rate here is our percent here. There's our percent, 7%. Now this is 7% as a decimal, so 7% is the same thing as if you move it, turn it into a decimal. The decimal starts there, and you move it over twice, right? So it's 0.07 as a decimal. So we put in 0.07 all over number of compounding periods, which in this case annually just means 1. So we'll put a 1 there and a 1 there, because that's where the compounding periods go. And then T is the number of years. So this one is 4 years, so we're going to do times 4 here. Okay, and A is the current amount, so that is what we're actually looking for. How much will it be worth? So that's the current amount. All right. Now we should be able to put this all in our calculator, but often I'll have noticed that people will put this into their calculator, and they won't do this in parentheses. They'll enter this incorrectly into the calculator. That's the most common error. So I often suggest to people to just simplify this here first. Leave everything else the same. So 5,000 times 1 plus 0.07 over 1. And then 1 times 4 gives us 4. Now we can enter this here into the calculator, and we'll be in shape. Okay? Good shape even. 5,000 parentheses 1 plus 0.07 divided by 1, and we don't really need to divide by 1, but we'll just do it anyway for good measure. And then we're going to take this all to the 4th power, and that gives us $6,553.98. So, oops, A equals 6553.98, I think is what we ended up with, right? Let's just double check here. 6553.98. Okay. All right. So that's how much it's going to be worth in 4 years. All right. Let's take a look at another example, and this will be example 11 from page 409. This one has us investing $25,000 at 9% per annum, which is, they'll abbreviate as PA, and really what that means is per year. Okay, for 3 years, how much will there be if the interest is compounded quarterly, and how much will there be if the interest is compounded monthly? So really we have 2 different problems to try here. So let's solve these things. Let's start with our formula. P times 1 plus R over N to the NT. One quick side note here. This formula here is a little bit different than what the book gives you. This one just seems to be much easier to use. I'd be happy to show you how to use the book formula. They they make it a little bit more challenging with their formula. So we're trying this one out. Okay. All right. So with this one here, we are looking for how much will there be if the interest is compounded quarterly. So we're looking for the A. So that's what we're solving for. So we got to find all these other pieces. P, the initial investment, $2,500, excuse me. $25,000 times 1 plus R is our rate as a decimal. So there's 9%. So it's 0.09 divided by N, the number of compounding periods, which is quarterly. So that would be, quarterly means there's 4 quarters in a year, right? So those 4s go there. And then the T is the number of years, which in this case is 3. So 4 times 3. So we used all of our information here. Okay. So again, before putting it into the calculator, it's going to make your life a lot less painful if you just simplify the power here first. So it's really 25,000 times 1 plus 0.09 divided by 4, all to the 12th. Okay. Now, just really quick before we actually calculate this out, I want to explain what this in here means. This here is basically what we're going to end up, you're going to multiply by. So you're going to multiply, this is basically your interest that you're multiplying by. So, for example, let's see, we take our 1 plus 0.09 and we divide it by 4. And that gives us 1.0225. Because basically you have 9%, the interest is 9%, but that's only 9% per year. That's not every quarter. Okay, so what you have to do is you have to take that 9% here and divide it into 4 equal pieces. So really you're getting 2.25% 4 different times in a year, which gives you your actual 9%. Okay, so that's what this is all about. So if we take that number here, and again, we haven't calculated our final answer here. I'm just trying to explain what's going on here. If you multiply that by $25,000, that means after 3 months, because that would be 1 quarter of a year, that's when you would get your first interest statement, your interest compounded, your calculated, excuse me. So you take the $25,000 and you multiply it by the 1.0225%, and now you're, instead of 25,000, you're now $25,562.50. Okay? So, what we really want to do, sorry, I'm just trying to explain everything as to what this stands for. I figure you have a lot better chance of doing well on this if you understand what you're calculating. Okay? So, let's put this all into our calculator, 25,000. And then we have parentheses 1 plus 0.09 divided by 4. And we're going to take that all to the 12th power. And we get 32,651.25. So we get $32,651.25. And that is how much you would have if you left that invested for 3 years at 9%, and you compounded quarterly. All right, so let's try the same thing, but now we're going to do monthly here. So we have A equals P times, oh sorry, we don't even need to do that. Really all we need to do is we're using this exact same formula, but instead of quarterly, now we're doing monthly. Okay? So I know we're having lots of fun here, so I really think we should probably put our party hat on for this last one. So let's see if I can get that to work. There it is. Yay. It's time for a party. We're having one. Monthly. So we're going to take this 25,000, and then we're going to do 1 plus. The interest is, sorry, the percent rate is the same, which is still 0.09. And now instead of compounding quarterly 4 times, now we're doing monthly. So that means this is going to be 12. So this is going to be to the 12 times 3. So really what we want to stick into our calculator is 25,000 times 1 plus 0.09 over 12. All to the 12 times 3 is 36. Okay, so we'll try that in our calculator. So we do 25,000 times 1 plus 0.09 divided by 12. Close our parentheses and take that to the 36th power. And we get 32, 7, 16, 32, 13. So 32, 7, 16, 13 is the amount left, that amount that you have if you've invested $25,000 and it's been compounded monthly. So if you'll notice, the difference between these two is not a whole bunch. It's only what, about 55 bucks or so? Yeah, it's not a whole lot. So actually it's what, about 65 bucks. So anyway, there's not a big difference, but there is a little bit of difference. So really the quarterly, monthly, if these all stay the same, this should not make a big difference. It doesn't make a big difference. So if you find that you have a big difference on your answer, you might want to double check. Okay, we got one more example. I'll put that on the next video, and we'll pick it up there. All right.